Let us in brief now look at the process of designing one of these IoT-based embedded systems. We'll first discuss the need for a design methodology in designing an IoT system. We'll then look at a simple design methodology, a simple but generic design methodology for designing such systems. And then we'll zoom into the individual steps of the design methodology. And then we'll move on to have a look at other alternative design methodologies. The IoT systems that we have framed as indicated in the diagram here, composed of the three tiers, would have multiple features to it that need design. First of all, this would be a user interface through which the user can interact with such a system. The first part of this user interface would be, or the main part would be on the remote terminal, where a user remotely can be able to view and monitor and control the IoT application. The second part, major part, would be the software application that sits on a remote server, which would typically be able to store or contain most of the intelligence of the system. That is, whose main functionality would be to process the data that has already been extracted by the lower perception and control layers. Now, the core of the design challenge in this lies with the embedded systems that are at the perception and control layer. Now, at this layer, we have this wireless or wired sensors and actuator nodes, which sit paired to the appliances that are supposed to extract informative data as well as effect the control instructions. So the design challenge here would be mainly in hardware, which deals with interfacing this embedded system with the appliances which is attached to it, or the environment in which it resides. And there will also therefore be a software algorithm which can be used then to gather data as well as issue instruction. There might at times also be a user interface, a form of user interface in which a locally located a local user can be able to interact with such an embedded system. For the purposes of this module, we will use the design process depicted on the left. The design process is made up of multiple steps that the designer has to go through, or the design team has to go through. Tied together with these steps are a set of deliverables that need to be given, and this can serve as milestones too, in order to ensure that the design team knows that it has achieved, it has successfully completed each of these steps. So the first of these steps would be requirements gathering or requirements elicitation, as indicated. So during this process, the design team will gather requirements of the system that needs to be designed, and at the end of that process, the design team will have a comprehensive list or documentation of the requirements. And then the design team then proceeds to analyze the requirements in order to see which can be actually implemented in the project, and how the requirements can be grouped and met by the upcoming design. And this will result into a comprehensive detailed list of specifications. That is the system's specification, the specification that the system needs to have in order to be able to meet the requirements that were earlier identified. And then using the specifications, the design team then starts the process of designing in two key phases. First of all, it will be the architectural design, and after the architectural design, the whole process will result into a higher level design. It will indicate the main components of the system and all the and how each of them would be interfaced to the other. Now, the design team then will choose to go into the detailed design of the key components. Key to this component will be how it will design the hardware. In this case, this might involve choosing the correct hardware platform, and that can be used, that is the right microcontroller, the right programming language, and so on and so forth. In our case, of course, this is restricted to Arduino and ESP8266. And then the design team will also then have to consider separately the design of a user interface, and then as well it will have to consider the design of the software that sits inside the embedded system. In this case, this might be in a simple form of an algorithm using a flowchart to show how the system would be behaving. And then once all of this has been done, then the design team will then integrate all of this into a single system and do the testing to ensure that it works. And then finally, the system will just be deployed. Now, we have demonstrated that therefore then the whole system can be designed from top to bottom into that top to bottom approach. Sometimes when the system is well known, it can be easy also to use the bottom-up approach. In the bottom-up approach, what tends to happen is that after the requirements and the analysis of the requirements has been done, the design team can decide now to start designing the details of the system, that's the specific hardware, the specific user interface, the specific software, or the specific blocks, and then see how then those specific blocks can combine together to create the ultimate architectural design for the whole system. So in that case, then the design team is able to start with the smaller modules and integrate it backwards to form the complete system. But this, of course, it assumes that the design team is able to anticipate what would have been like the overall requirements of the system and how each of those components can be able to meet those requirements. So it is much harder, in fact, when a project is new, to be able to start this process from the bottom going upwards. Let us take a break for now and watch part 2 next.